Guys, welcome once again to my YouTube channel. For today we continue with differentiation, and today we are looking at quotient rule. So guys, welcome as we begin the lesson. So today guys, we have these questions to solve and we are going to use the quotient rule, but we are also going to use the chain rule and the quotient rule. So I place my paper there so that I can also refer to this, what we call the quotient rule. Quotient rule applies where you are dividing two numbers. For example, here you are dividing natural log of 2x over x plus 1. That is division. And this one you are dividing 1 plus x over 1 minus x. So this is where we use now the quotient rule. So let's begin with the first question. We use now the quotient rule for this one. So we say that is question number 1 to be like this. We shall say this be given as u. That will be, let me write it there, y equals to natural log of 2x all over x plus 1. So we can say this one we give it u, while this one we give it v. And so here we shall say u is equals to natural log of 2x. So this one, when we differentiate it, we will have natural log of 2x. So this one we use chain rule. First of all, we assume that whatever we have here is u. So if u, not really assuming, we let 2x be u. So the natural log of u, whereby this one is like saying u is equals to in, and then we have a number here, we can give it maybe an a. So we can say a is equals to 2x. So dA all over dx, this one is 2. And then we have du all over dA. This one now gives one as 1 over a, because that is the differentiation of natural log. It gives us 1 over a. And so when we come to this one, finally we have dA over x multiplying by du over dA. We shall remain with d, that is du all over dx. So this one will give us, this will be 2, you multiply by 1 all over a, which is 2x, like that. So this is what we get. So what normally happens, guys, is that the chain rule, we can actually be able to do it without having to write all this. So what I'll do here is that I'll come and say the natural log of a number is equal to 1 over that number, which is now 2x. And then I come to that number and differentiate it again. If I differentiate 2x, you are going to have 2. And you can see it looks like that. So finally I can cancel that, and then we are going to have 1 over x. So this is the differentiation of this, we call it, is supposed to be du dx. which is similar to this. So now guys, we continue. We continue now to V. V is equals to x plus 1, and so therefore dv dx is going to be equal to, if you differentiate x, you get 1, like that. So applying our equation, the quotient equation, it's written like this: v du dx minus u dv dx divided by v squared. Or in short, we can write it like this: v du minus u dv all over v squared. That is also another way of writing it. So finally, guys, this is what we shall have. Our dy dx over dx will be, our v is x plus 1. V is x plus 1, like that. Du dx is supposed to be 1 over x. This is 1 over x minus, we now come to u. U is natural log of 2x, and it is here. Then we have dv dx. This is 1. We don't need to put it. All over v squared. V squared is x plus 1, and then you square this v, like that, like that. And so guys, this is our answer for that question. We don't have to simplify it, we can write like that. So guys, we now go to the next question. So the next question reads: differentiate log e 1 plus x over 1 minus x is equals to y. So we are differentiating with respect to x. So this one will be dy dx. This is going to be, now using this formula, we are going to have, maybe I can still write it again, v du dx minus, that is, this is now u dv dx u divided by v squared. And so guys, let's say that our u, this first term is our u, the second term is going to be our v. So u is equals to 1 plus x. So du dx is going to be, this is going to be 1. And then our v is going to be 1 minus x, like that. So dv dx, this one we will have -1, like that. We can first of all leave it like that, and look at something, guys. And this is what I want us to look at. We can also say, we can retain that, but say y is equals to log e, and then we can say this is z. Let's say this is z here. Now we are going to use the chain rule. I have deliberately not said u because we have u here. So I say this is z, whereby z is now equal to this term. That is 1 plus x all over 1 minus x, like that. So that now, using the chain rule, we can say dy, let's continue like that, dz, this one is going to give us 1 over z. And then let's now come to our question here, where now we have this. So now, considering this one and this equation, then we would have to have, like, for example, instead of having dy here and dx, we will put dz all over dx, because now we are doing this question. So we can even change this one, and now first of all put dz like that, so that now we can use these values to find the dz. So guys, we do like this. We come and say dz over dx is equals to, this is our u, so our du dx is that. This is our v, so our v is 1 minus x, dv dx is minus 1. And so using this equation, we will have v, which is 1 minus x. That is the first term we have. So I have written the question here so that we can actually have it near us, so we don't make a mistake, or we are able to refer back to the question. So here we have the u. The u is here 1 plus x. This is dv. This is v, 1 minus x. Then we go to du. For du over dx, then we have 1. Then minus, you can put that into bracket. U is 1 plus x, and then dv dx, this is minus. So this one is going to change because of the minus here, minus 1. This is going to be over v squared. V squared is 1 minus x, and again 1 minus x, like that. And so guys, we continue. So this, we have used the quotient rule, and now we come to the chain rule. So we will have now dy all over dz, that is that. This one should give us, if you multiply with the dz over dx, this one gives us now dy all over dx for the question above, this question. So this one will now come to, let me put it here now. Before I put it there, maybe I could continue to write here, down here. Let me leave that one so that we can come here and say, now the dy all over dx, this one is equal to, we have dy here, dz, so this will be 1 over z, like that, and multiply now by dz dx, which is this. So this one will be 1 minus x plus 1 plus x, like that, all over 1 minus x, 1 minus x, like that. So finally, guys, we will get dy dx will be equal to 1 over z. We look for z. Z is this. So we will write 1. We write there 1 over z. Z is 1 plus x over 1 minus x. And this one we are multiplying with. This x can cancel, so we are left with 2 there. We have 2 there, and then we can draw a line there. Here we have 1 minus x, and we have 1 minus x there. In that case, this 1 minus x, we can put it up there. So now we will have, as we finish, this is dy dx. This one now gives us, maybe we can extend there and come here. We say dy all over dx. This one will give us 2 all over, here we put 1 minus x, and down here we are going to put 1 plus x, like that, and then 1 minus x, 1 minus x, like that. So this can cancel that and that. So finally, guys, this is our solution. The solution is 2 over 1 plus x, 1 minus x. So guys, we have our solution there. So guys, thank you so much for listening to me. Next time we meet.